Now let's look at rotary air blast drilling, which is in short called RAB drilling. It uses compressed air to power a downhole hammer that crashes the rock. So the unique thing about this particular drilling method is that it has a compressed air, and the work of the compressed air is to power a downhole hammer to crash the rock. So we have a down the hole hammer, and the down the hole hammer receives its energy or its power from the compressed air, which pushes the drill bit into the formation and crash the rock, penetrating into it. So that's the peculiarity about air blast drilling. And the cuttings are the cuttings when the drill bit is making the hole or is making the penetration. It has to cut the rocks. So those cuttings that are remain are borne to the surface through the annulus between the drill rod and also the borehole wall. Let me give you a diagram so that you understand. So this is the borehole. Okay, so let's say this is the borehole that we are making, and this is the drill bit that is making. Sorry, let me do my diagram where. Okay, so this is the drill bit. This is the walls of the borehole or the drill hole. Okay, so as this drill bit is cutting the bottom of the drill hole, there are some the cutting that are made are they remain in the borehole, okay, the drill hole. So they need to be brought up to the surface. Okay, and the compressed air passes through the drill rod, gets through the drill bit, and bottom of the drill hole. Okay, so when it gets to the bottom of the drill hole, by the pressure at which it is moving, it forces the cuttings which have been made inside the borehole to move up, to push up out of the drill hole. So these cuttings will move in this direction. Okay, so they pass through the annulus hole. That those small holes between the drill bit or the drill rod and also the walls of the drill hole. So this is the drill hole. This whole space is the drill hole, and this is the drill rod with the drill bit. So these cuttings, which have been made at the bottom of the drill hole, is pushed up to the surface through the small holes in between the drill rod and the holes of the drill bit. And it is pushed up by the compressor. The compressor passes through the drill rod, gets to the drill bit, hits the bottom of the drill rod, drill hole, pushes every cuttings inside of the surface. So that's how it happens. What happens? Now the air blast drilling, that is the RAB drilling, is best for rapid and inexpensive drilling in relatively soft to medium hard rock. Okay, so when we are dealing with a foundation or formation that is soft, we can use the air blast drilling. And if the formation is also medium hard or soft and hard rock material, that is its medium, then we can also use the air blast drilling. So this air blast drilling is designed for soft rock materials and also medium rock materials. Okay, and normally we can apply it for reconnaissance exploration and initial target testing. When we get to have our target, then we just want to test the target of the presence of any mineral. Then don't need to dig very deep into the ground. So by the surface now, we can put some samples uh, to help us do some analysis before we can now come back conclude that we want to dig deeper into the target ground. Okay. So we can use the air blast drilling for such a method. So this is an air blast drilling in action. So the dust the dust will confirms the presence uh, of compressed air that is being used. So you can see how dusty the area is. That means that the cutting that was inside the borehole or the drill hole is being blown up by compressed air to the surface. Now let's look at some of the advantages of air blast or the RAB drilling method. First advantage is that it has a fast penetration rate and it is relatively inexpensive. So comparing the air blast drilling method to that of the RC drilling method, you can say that air blast drilling method is relatively cheaper compared to the RC drilling method. And if you want to experience or you want to have a fast penetration rate, then you can use the air blast drilling method. Remember that the fast penetration rate that this one is having is because we are drilling through a soft formation and also a medium hard formation. We are not drilling through a hard formation. So when we are dealing with soft formation and a medium hard formation, then we can use the rotary air blast drilling method to achieve our target. Okay, and remember we are comparing it to the organ drilling in terms of drilling through soft formations. With drilling through fast formations, the rotary air blast drilling will give us a faster results or a faster penetration rate compared to the organ drilling. Okay. Then limitations are that is poor sample quality because it is using the compressed air to force those cuttings up to the surface. Those samples or the cuttings cannot actually represent the true, cannot actually be used for to represent the true nature of the ground of where we obtain the sample. Because when it comes, it will be mixed up, and it can also come with extra foreign materials because it's being grown. It is not well received. It's not well coordinated and received. The dust up. This thing can actually cause those samples to be contaminated. And especially when we are dealing in a wet ground, because it's mixing up with water, the sample will become contaminated. And it is limited to a depth of less than 150 meters. We can't go beyond it. And when we're using the air blast drilling method, we can only drill up to a depth of 150 meters. Less than 150 meters. But beyond it, we begin to have issues. It's not suitable for fractured or unconsolidated ground when you are dealing with ground that has a lot of fractures. In such an area, you cannot have a good drilling. And why is that so? Because we are using compressed air to blow the cuttings to the surface. So we need to have the walls of the drill hole to be solid. Okay, we don't want to have any fractures within the drill hole. Because when you are blowing the cuttings to the surface by the compressed air, because there are fractures within the drill hole, those the compressed air will not be effective because it will end up escaping through the fractured holes. So you will not have the cuttings being well known to the surface. But at the end of the day, the cuttings will remain in the drill hole and it will end up making our work difficult. If the cuttings are not removed, That means that the drill bit will not have direct contact with the rock formation. And so it will reduce penetration. The rate of penetration will reduce, and we will have a lot of chokings. And the drill rod will have a lot of choking because of the presence of the actions within the hole. And so we need to remove the cuttings from the drill hole. And since the compressed air is not giving us achievement because of the presence of functions within the hole, then our work is going to be difficult for us. It's very, very important. Then it's not that control can be an issue. So first we are doing it with compressed air, by all means, there will be a lot of dust. And mass is going to be a very serious issue in terms of safety. The workers there are going to experience so much dust. This one can be common applications. We can apply it in reconnaissance exploration, initial testing of soil geochemical anomalies, drilling through overburden to reach bedrock. Okay, so these are some of the common applications of the rotary air blast.